So we're going to start the recording now. So my name's Jamie McCutcheon. I'm the presenter today. I appreciate everyone getting on and sharing your lunch hour with us. We're going to be talking about skimmer sediment basin design. Hopefully you'll find this a very technical, educational presentation. This is being done as a meeting. So, if you want to send a message through chat, or if you want to unmute yourself during the process to ask a question, we're probably going to have around 50 people or so on here. So should be able to manage a few questions, and we'll definitely have room for questions at the end. Also, I'm going to be friendly and turn my video off so you don't have to look at me. So we'll just have the share of the screen here. All right. So again, my name is Jamie McCutcheon. I'm a 92 graduate of Clemson University. I am a professional engineer. Had my own engineering company, excuse me, CCAD Engineering, for almost 20 years. Got acquired by a larger firm about 3 years ago. 2013, I invented the Marley Float Skimmer, and we founded SW Products, which we rebranded as Rymar Waterworks in 2018. And as I said, I am a professional engineer. I'm licensed in South Carolina, North Carolina, and Georgia. So today we're going to have a couple of objectives. We're going to first just kind of understand, for those of you who are not familiar with what a skimmer is and why it's used. Talk about the very fundamentals of skimmer basin design. Then we'll go into a little more advanced but basic design tools. And then finally, we're going to talk about advanced skimmer modeling in SEDCAD and other hydrology software. And at the end, we're going to talk about a few other products that Rymar has available just to make you aware. So most of you have probably seen a pond without a skimmer before. I know they've been around now for varying about 5 to 10 years, depending on your location. But what we used to do is a perforated riser. We'd have a hole at the bottom orifice, and that would let in a lot of mud, as it discharged. You had a riprap or stone ring around it, which probably did a decent job of filtering out some of the mud, but a lot of them looked like this, and it wasn't the best way to trap sediment. So EPA is now requiring surface withdrawal from sediment basins in most areas. And the way we meet that is typically with a skimmer. So it withdraws from the surface or near the surface. Our specific skimmer takes in water from just below the surface, around 8 to 16 inches below the surface. And this has an advantage of excluding any trash or debris that's on the surface and limiting the clogging. As I mentioned, the EPA is now adding this to most states' construction general permit. This is the Ohio permit language, but most are pretty similar. And they say something along the lines of, when discharging from sediment basins, utilize outlet structures that withdraw water from the surface unless infeasible. And in most cases, there's not many times that it's infeasible. Sometimes if you're in a cold a climate that has a lot of ice during winter, there could be a period of time when you need to have an alternate withdrawal method, because skimmers and ice don't always work well. But in most cases, you're going to be required to have a surface withdrawal from your basin to meet this requirement. Currently, there are about 30 states that have this in their construction general permit. It seems like more are being added each year, so this list may be a little outdated, but there's most of the Southeast, and it's kind of going towards the West. There are a few states that have gone past skimmers, such as like Maryland and Washington State. Now require a lot more treatment of water before it's discharged. And some other states are just now coming on with skimmers, such as Texas is just starting to see those being enforced there. So it'll help me just a little bit. We're going to do a quick poll. And if you could let me know where you're located. So we sent this out to a large number of folks on our mailing list. And I'm always curious to see, where you are that you ended up being here. So got just a couple more to respond. And we'll go ahead and end that, and we're going to share those results. So it looks like South Carolina and Ohio have the most. North Carolina, Georgia, Tennessee, Kentucky are few, and about 3 folks from other places. So we appreciate the good range we have with us today and appreciate you joining us. So we'll get into the 3 fundamentals of sediment basin design, and those are really simple. It's volume, time, and flow rate. So the first fundamental is basin volume. So the basin volume is based on the area flowing to the basin. Now, regulations do differ. Some require the total area flowing to the basin, and some base it on the disturbed area flowing to the basin. There's 2 kind of general standards out there. One is 3,600 cubic feet per acre flowing to the basin, and the other is 1,800 cubic feet per acre. But for this example, let's assume you had an 8-acre site that's flowing to your basin, and it was a 3,600 cubic feet requirement. So you'd have a required volume of 28,800 cubic feet. Some areas also require basins to have a permanent pool or sediment storage that's not drained by the skimmer. Ohio is one of those for sure. That is their standard. There are some other states that have that as well. And one of the key things to recognize, and we see often on plans, we recommend you use the required volume of the basin and not the actual volume to size your skimmer. And we'll talk about that a little more later as well. So fundamental number 2 is dewatering time. So sediment basins work by allowing time for sediment to settle to the bottom. And obviously this time required will vary based on the soil type. If it's a sandy soil, it'll settle very quickly, typically within, even just a few hours or minutes even. But silts and clays can take much longer and often are very difficult to get to settle. So with the most common standard that we see across the different states is a 2 to 5 days or 48 to 120 hours. But this does vary from state to state and even from MS4 to MS4 within states. And so the third fundamental is flow rate. And so it's a simple calculation of basin volume divided by your dewatering time will determine your flow rate. And you can use the minimum dewatering time to get your maximum flow rate and vice versa, maximum dewatering time to get your minimum flow rate. So for our example, if we had 28,800 cubic feet and we wanted to drain it in 2 days, we'd have a skimmer that flowed at about 14,400 cubic feet per day. Or if we wanted to drain it over 5 days, we'd have a much smaller skimmer or reduced flow of 5,760 cubic feet per day. It is worth noting that a lower flow rate will often result in a smaller and typically less expensive skimmer for your contractor and client. Now, one thing that we do like to point out is, contrary to popular opinion, skimmers are not constant flow devices. They actually do have a flow rate curve, and the testing of skimmers has shown this with all different types and models and brands of skimmers consistently do have some sort of flow rate curve. So to demonstrate this, this is a test that TRI Environmental did. They did testing on skimmers for the state of Georgia when they were revising their green book, and they tested 3 different 3-inch skimmers. And you see 2 of them had pretty similar flow rates. So at 1 foot of depth, they were flowing around 37, and this is in gallons per minute, while another 3-inch skimmer was almost double that at 70 gallons per minute. All 3 skimmers had an increase of about 25% of their flow rate as the test tank went from 1 foot to 4 feet. And so as the depth increased, the flow rate increased. 2 of them were still fairly consistent, 47 to 53, and the other was nearly 90. So the point is, if you simply spec a 3-inch skimmer or a whatever size skimmer, you may not be getting the flow rate that you actually thought you were, depending on what skimmers used or if a contractor decides to make their own. This is a flow rate curve chart for some of the Marley float skimmers. And as you can see, most of them are stabilizing around the 4 foot mark. So this is a 0 to 4 feet of depth, and this is the flow rate. Our 4-inch with no orifice has a pretty big flow rate curve, going from about 100 to almost 170 GPM over that depth. Most of the others have a little lower flow rate, a little smaller curve, but they all do show an increase of flow from 0 to 4 feet. One of the other interesting things as you do your sediment basin design, skimmer basin design, is what are the different state standards? And I think we're actually covering states here that a good many of you are from, but it is interesting to see how they differ. So for example, basin volume in South Carolina, that's 3,600 cubic feet per acre. In some areas, they define that as disturbed acreage, and others they say total acreage. North Carolina does define it as 1,800 cubic feet per disturbed acre for your basin volume. And if you're doing a trap, that is one that doesn't have a skimmer that flows through stone, which we don't see many of those in North Carolina, the volume is nearly double. Georgia has an 1,800 cubic feet per acre, as does Ohio, but Ohio also has this additional 1,000 cubic feet per acre for disturbed area. So their 1,800 cubic feet is based on total area drained into the basin, plus this additional 1,000 cubic feet, which is below the skimmer outlet, which is a permanent storage of 1,000 cubic feet. In Kentucky, particularly this is in Louisville, where they've got the actually have a soil type dependent volume. So you have to calculate your volume based on your soil type. The surface area is fairly consistent. There's two different formulas. There's a 325 square feet per CFS for a 10-year storm, or a formula for flow based on a 2-year storm. If you run the math, these come out fairly similar to each other. Ohio doesn't have a surface area requirement, but has a maximum depth. And again, Kentucky makes you calculate it. Principal spillway, this is typically the skimmer and maybe your outlet structure, your riser. It needs to handle anywhere from the 2-year to 10-year storm in most cases. And the emergency spillway, which would just be your overflow, can be designed anywhere from the 100-year to 10-year, with 25-year being common in some other states. The skimmer requirement is interesting. South Carolina requires it if you have 10 acres or more going to a basin. It's preferred for smaller areas, and some MS4s do require it on smaller areas. North Carolina seems to require skimmers on nearly all basins. We've seen some, I'll say, large mud puddles that had skimmers on them. So getting a skimmer small enough to drain those and take 2 days can be a challenge sometimes. Georgia, it's technically not required in their manual. It's preferred. They still do allow retrofits or perforated risers. However, we're seeing more and more MS4s actually require those in Georgia, so it's becoming more common that they have them. Ohio, it's about a 10-acre site is required, and in Louisville, it's typically 5 acres or more. And then the other big varying item is dewatering time. 2 to 5 days is a very typical standard. Georgia does not give a time frame, but leaves it to the engineer, so you can vary that based on your soil type. And Ohio has a 2 to 7 day standard that they require, so you allow you a little bit longer. Some states, if it's in a pristine water area, protected watershed, may even require a minimum of 4 days. And then Kentucky, it makes you calculate to make sure you've got an 80% trapping. Most of these others, if you combine the basin volume and the dewatering time, there's some imperial formulas, and they are kind of assumed to hit a minimum of 80% trapping. So we've developed a couple of design tools to help make this simple. So if you're simply doing a fundamental volume time, calculation, you can use this tool. It's available on our website to download. So, for this example, we give you a couple of different places to put in your data. So your date, project name, location, your engineering company, engineer name, your basin description. And then we have a reminder up here to help you with that required dewatering volume. So again, we have your acres to the basin, and then your cubic foot required per acre to come up with a volume. And so, this is a pretty easy calculation. You can change this acreage or the required volume per acre as needed to fit your area. Maximum time to drain and minimum time to drain, we recommend that 2 to 5 days, but it may vary. Your pond depth. Now, your pond depth is going to be the volume that's controlled by the skimmer to get you to that calculated pond volume. If your pond's 6 feet deep, but you only need 2 feet of depth to meet that required volume. That's what you want to put in here, not the full volume. And again, the top length and top width and bottom length and bottom width, and we recognize they're very seldom a square or rectangular pond. So you adjust those based on your engineering judgment. It will calculate the pond volume for you based on that information. And you want to try to get it within about 5% or so. We're trying to hit a 2 to 5 day time frame, so you don't need to go back and forth through this thing to hit exactly 61,200 cubic feet. We've got slightly extra volume than that, so we should be good. So once you put this information in, it will run the calculations for all of our skimmers and orifice configurations. I know you can't read that, but it's just kind of showing the spreadsheet that we have. And then down here at the bottom, we have a skimmer report page tab. If you click on that tab, it'll take you to a nice, neat report that you can use in your stormwater report or on your plans. Gives all the information that you put in, including your name, your sediment basin description. Highlights the required volume and the calculated pond volume to make sure they're similar. Gives you the minimum flow rate allowable for the maximum time and the maximum flow rate for the minimum time. And then because this is our tool, it tells you what each of our skimmers would do as far as drawdown time. So it'll tell you the hours, and then based on what you specified, the 48 to 120 will tell you which skimmers meet that requirement. So in this case, you actually had 3 different size skimmers to choose from. You could go with a smaller 3-inch skimmer, and it would take a little over 4 days for it to drain. You could go with our larger 6-inch skimmer and drain it in just over a day, or pick one of the middle-sized 4-inch skimmers that can get close to that 3 days. Really, it's up to the engineer. We generally suggest trying to hit somewhere around that 3-day, 72-hour time frame. But if you've got a site that's sandy soils, you may go quicker. If it's really clay, silty soils, you might want to consider a little longer. But you want to keep in mind getting the basin drained before you get another storm event that would top the basin. Again, just highlighting, make sure that your required volume and your calculated volume are close to each other. And then, make sure you specify in your design which skimmer you prefer to be used. Now, in addition to that design tool, we have some sediment basin details that are available also on our website. They're in CAD or PDF. You can modify as you need to. They're not locked. A couple of things to point out. You specify the minimum volume required, so you can change that to meet whether it's 1,800 cubic feet or 3,600 cubic feet. Your surface area. One of the key things is specifying this minimum and maximum dewatering times. So putting that on your plans up front, that way it gets reviewed by the reviewer. And then we have a data block, and it's for multiple basins. You can expand it as needed. So it's got your drainage area, disturbed area, your flow rate. Now you may change this to your Q2 depending on what your local requirements are, but typically the 10-year storms what we're looking at. Basin volume, again, you're required and provided, and your provided may be much larger if you've got a multi-purpose basin that's going to be your detention pond. Surface area, outlet information. And here we have your skimmer size, your skimmer orifice diameter, your skimmer manufacturer, because again, not all skimmers are flow the same. Is an equal allowed, yes or no? And typically that's going to be yes. There may be some rare circumstances where you say no for a specific reason. And then your skimmer flow rate. So you spec the minimum and maximum flow rate. And again, our tool helps calculate that. And then if someone does want to use a different skimmer than what you specified, then it's very simple to make sure that skimmer has that flow rate based on the manufacturer's specs. And so, if you put this in up front, it's reviewed up front, then it should be a simple shop drawing review and hopefully avoid having to go back through a full review. This detail just has a pipe through the dam and a emergency spillway. We have other details that have a riser structure here that you can add as well. We also have a tool that calculates not only the required dewatering volume, but also the required sediment storage volume. Tools are very similar, we just added the sediment storage volume to help with that calculation. Again, it has the same, trying to help you specify the required and make sure you calculate it based on that. Again, this is just a blow up of that same page. And here you can select the skimmer that's maybe closest to the 72-hour time frame. So very similar tools. The only real difference is one has that permanent volume for sediment storage and the other does not. And then we also have pond details that have both of those in them too. So we have the required dewatering volume now and the sediment storage volume on this detail. So here you can see the skimmer set above the bottom of the basin. So this would be your sediment storage volume. We have a place here to put that in, as well as dewatering volume. Everything else is pretty similar. And we just added to this column the required sediment storage as well as the required dewatering volume. So again, this is the one with the outlet structure. We generally suggest that the skimmer be parallel to the dam. That just makes it easier to inspect, and should it get clogged, easier to pull over. Now they'll have a flexible coupling, so they can be pulled to the side if they're stubbed out. Our particular skimmer has a fairly rigid coupling that kind of helps keep the skimmer in place so it doesn't move around too much. But other skimmer brands may have a more flexible coupling, kind of allows it to move around, and if it's on the side, it may get stuck on the dam. So I'm sure many of you have probably seen this, but just a couple of pictures. So this is a skimmer installation that shows a common issue. So the contractor went and graded the basin, and obviously this is just graded. He's got his baffles in, that's great. He put in a stone pad, but he put it on top of the graded surface. So now what you've got is about 6 inches of pool volume in here. Now, if this basin is supposed to be a dry basin, you're going to have a hard time getting grass established on the bottom because it's going to stay wet most of the time. A lot of times we recommend that this, we call a skimmer pit, be a little bit graded down, and that stone basically at grade level to minimize that permanent volume. We've seen some really bad installations. This is one that a contractor did. There's just so many things wrong with this, it's hard to say, but you don't even need the stone ring when you have the skimmer. It doesn't hurt necessarily, but the skimmer's on it. This pipe can't flex at all, so the water's just going to go through the top of the skimmer and over the floats. It's not going to float up. They even have this side open. So it's just an example of really bad contractor installation. This is a recent one. We didn't realize that people would not know how to install them right side up. So this one's actually turned upside down and flipped around, and the skirt upside down. And so I don't know that any water can get here. Also, unless this pond's 6 inches deep, that pipe is not near long enough to float up hardly at all. So we try our best to make these as simple to install as we can, but unfortunately we've seen some really crazy things in the field. Also, skimmers do require maintenance. This is one that actually had vegetation growing out of it. And so if you see a skimmer with vegetation going out, there's probably a problem. So there's a huge root ball reducing the flow in this one. And as well as you can see, there's mud here that's below the pipe connecting to the outlet. So it's not able to sit down. So anyway, I know enforcement of maintenance can also be a problem, but it is something to keep an eye on. So I know the folks that are on here from South Carolina, at least some of them have used SEDCAD, and Kentucky also, I believe, is using SEDCAD. For those of you who are not familiar with SEDCAD, we're going to run through this. This is a sediment modeling software. So if you're trying to calculate your 80% trapping, it's a good option to do that. So this is a site we're working on, an existing warehouse facility. And they wanted to add an additional warehouse, and we're going to add a detention pond, which was going to be our during construction sediment basin down in this corner. I'm not going to go through all the details of SEDCAD. A lot of the setup is similar to other hydrology modeling software, but if you do have questions about it, please feel free to reach out to me, and we're working on some more in-depth videos make available for each different software. But in this case, one thing to point out, in your dead space, if you're using baffles, typically you can move that to 0. 20% is kind of the conservative, but you can use 0 in most places if you have baffles in place. So you're going to build your pond with your stage storage volumes. So this is your elevation and contour areas, to build your basin here. In this case, the engineer had specified a slight sediment storage area, although not required. It kind of helps limit the maintenance during construction. To allow that, it was about really had 6 inches. You can see a bottom of basin and skimmer decks with just a 6-inch volume there to allow for sediment. The key thing here, when you build your pond, your elevation area table, there is a feature over here for stage increment, and you want to set that to 0.1 feet. And when you do that, that'll give you a place to put in other values later. So that's one of the keys when you're using SEDCAD and modeling the skimmer, set that stage to 0.10. You'll then build your outlet. You'll have an enhanced perforated riser, assuming you have a riser. If you don't, if you just have a pipe through the dam, you just use it, the user input discharge. But in most cases, you've got a riser as your kind of secondary, primary spillway. And you put in whatever riser information. In this case, it was a 48-inch riser diameter, 7 feet tall, etc. After that, you're going to put in a user input discharge. And so when you do that and put user input discharge, the table here is going to give you elevation at every 0.1 feet. And when you do that, you'll have a place to put in the skimmer flow rates. So on our skimmer details, we have a flow chart that goes from 0 to 4 feet for each orifice size for that skimmer. And all these flow rates have been third-party tested and verified. And so that's a blow up there. So you'll have it in CFS. So we've got 0.1, 0.3, 0.5, and then every half a foot up to 4 feet. Now, if you go deeper than 4 feet, you can either maintain that flow rate, or SEDCAD may make you go slightly higher. So add a 100th or 1,000th of a CFS to it, or you can extrapolate it out. And so you just plug in your values as you have them. SEDCAD will calculate the differences for you. So this is spillway discharges put in. The other thing, if you would like to calculate the flow rate deeper than 4 feet, although our testing only went to 4 feet, it did establish a flow rate curve. So you can use our design tool and put in a deeper pond depth. And then based on that pond depth, it will tell you what the flow rate is at these increments. So it may not get you exactly to an even half a foot or foot, but you can get pretty close, and then you can pull the skimmer flow rate off of that. And this is on the spreadsheet side of the tool, not the report page tool. So once you put that in, SEDCAD will run the calculations. In this case, we've got a trapping efficiency of 80%, which is what we're looking for to meet a minimum of 80. We got 80.1, so we just barely met our 80% requirement. The dewatering time in this case is less than 48 hours. We've got 1.52 days. Now, in some cases, as long as you meet that 80%, that's okay. Other times, you may have to put in, change your outlet structure, either a smaller skimmer or change something in your riser structure in order to hit that minimum 2-day time frame. The other thing to really know, and we've tried to highlight here, SEDCAD does a sediment graph to show you, the sediment in and sediment out. However, SEDCAD does not take into account the surface withdrawal effect. SEDCAD assumes that water is coming through the entire water column, so top to bottom. And so if you factor in the surface withdrawal, you would expect the actual trapping efficiencies to be higher than what it calculates. We have used this successfully in some MS4 reviews. Let's say you hit 78, 79%, or even 77%, and you keep working on your pond and it's just hard to get there. We've been able to put in our narrative and explain that SEDCAD's basing the sediment trapping on coming through the entire water column, and reasonable engineering judgment would expect that you'd get a few percentage higher trapping, with the surface withdrawal of the skimmer. Not accepted everywhere. We've had some places push back, but in a lot of places they will accept that. Again, this is the final chart, showing you met your 80%, showing your peak inflows, outflows, peak sediment in and out, etc. So again, if you have any questions as we go through here, please let me know. I'm happy to take either questions or chat. So we're going to get now into the permanent use of skimmers, and we're going to launch another poll here. So be interested to know, what the folks' view and what your thoughts are on permanent use of skimmers. So if you've thought about it, no, hadn't thought about it, or yes, you've actually done it. All right, most have responded, so we're going to end that. So pretty even, either have never thought about it or thought about it but not done it. And a few of you actually have used it for permanent use. So we want to talk more about, oops, I didn't share the results. There you go. So we're going to talk about that now, about why you may want to consider use of skimmers permanently. So number one, skimmers can help with maintenance. So this is a case study, pond in Simpsonville, South Carolina, that we did some work on, and it was a nasty mess. It's got a huge area, a lot of commercial area, a lot of junk flowing into this pond. In this picture, this was before we did any work with the outlet structure. We just cleaned it up. It had not been maintained in quite a while. And when we did that cleanup, we found that the bottom of the pond had about 6 feet of muck in it. And so if you look at these pictures where you can see the lighter circles, hopefully you can see that on your screen, that's the old outlet. And it had a 2-inch orifice 6 feet below this muck. So 6 feet down was there. And so we worked with the county and with the client and redesigned this pond. It was an unusual pond. It actually had some extra volume. We raised the primary outlets, here, kept the top of the riser the same, but we went back in and put in a skimmer in place of this 2-inch orifice. That's slightly above the bottom of the basin. We probably, contractor should have installed it a little bit lower, but it is working pretty well, and it is helping to reduce the clogging. So the best example of that is about 6-9 months or so after we had done this, the contractor had gone out to maintain the pond and actually had cut all the vegetation, but had not gotten it out of the pond, and had a huge downpour. Had 5 inches of rain in just a few hours. But the pond did drain down. The skimmer didn't clog. If it had clogged, we'd at least been able to get to it to be able to maintain it, versus a 2-inch outlet down at the bottom. This riser structure, it's hard to tell here, but that's about 15 feet tall. And then remember, the outlet is 6 feet below the bottom. So, you'd have to get down in this thing. It's almost a 20-foot tall riser. And this was, about a picture on the right, is once they went back out and cleaned out the basin and got it, maintained again. So this one's been monitored for several years. I think we put the skimmer in 2014, and we continue to monitor it. We're also right now using it as a prototype for testing of some filter media. So we have R&D underway. We're going to talk about that a little bit later as well, to add filter media around the skimmer and use that media to take out TSS, metals, hydrocarbons, and other pollutants. And so it's a 2-stage system. Again, this is a prototype. We're going to probably be 6 to 9 months or so before we have it ready for market. But it is interesting that it's coming. And one of the big advantages to this, currently, if you're doing water quality in your basin, you're basing that design on a settling time. So you've got a low flow orifice. Sometimes those can be really small and hard to maintain, which again, a skimmer may be a better use to control the flow, or at least protect that low flow orifice. But with this new design, the filter will be doing your water quality. So you'll be able to let water out much quicker, probably up to your 2-year storm event flow rate, based on how fast the filter can, or how much flow the filter can handle. So you'll see a reduced pond size. The other advantage is 100% of the water from the water quality storm and below will go through the filter and get treated. Whereas, if you get like a very small, say a 1/4 inch rain and it hadn't rained in a week, that typically has no settling time, so it flows straight through your pond. So we're excited about this technology coming through, and right now TRI is getting ready to start our third-party testing to prove what our TSS removal rates are. So we're focused on TSS, but the media we're using can also take out hydrocarbons, metals, and a few other pollutants. We even have one that's going to be working on bacteria. So if you're going to use a skimmer permanently, you got to know how to model it as part of your basin. Whether you're going to use it now just for maintenance, or use in the future once we have a water quality benefits confirmed. So we're going to walk through modeling with HydroFlow. I'm sure most of you probably use HydroFlow since it's now baked into AutoCAD. So we're going to start with it. So this is a site that we worked on in the city of Greenville, South Carolina, and it was a fairly small site, but we're going to show how the Marley float can be used to reflect the peak rate attenuation, which is ideal in lieu of a smaller low flow orifice that's prone to clog. So we had about a 5-acre site. We had about 3 acres, or a little over 5 acres, about almost 6 acres. So 3.4 acres was oops. I had a quick question. Someone asked what the life expectancy of the skimmer in a permanent application. So we'll talk about specifics of our product, but we have our skimmer is an HTP product, so it's a 20+ year lifespan. The only piece that you may have to replace would be probably the pipe between the skimmer and the outlet structure if you use PVC. Anyway, so modeling in HydroFlow, we had 2.2 acres being disturbed, going to a little sediment basin. In this case, the city was asking for quantity control during construction. So not only do we have to meet sediment, we also had to meet quantity. And this site was flowing across a little side road to a catch basin on the other side of the road, so it didn't have a good outlet. So we didn't want to have any additional peak rate of water going to this road and potential liability. So pre-development had about 5.5 acres, curve number of 59, time of concentration almost 20 minutes. Post-development, obviously the undeveloped portion was the same. Our 2.23 acres had a curve number of 86. That's a disturbed condition clay soil, and time of concentration was down to 7 minutes. So we put in our stage storage table. Now here's the important thing. When you build this, you need to build in data points to be able to enter the skimmer flow. So as we talked about in SEDCAD, what our skimmer flow rates are. So we have a 0.1, 0.3, 0.5, and then a 1/2 foot to every 4 feet. And again, the details provide that flow information in cubic feet per second, so you can just plug it right into HydroFlow. So in this case, we had a culvert A, that's our pipe going out of the pond. So we had an 18-inch pipe going out, so our barrel. We had a fairly complicated outlet structure. So we had an orifice, C here was a 6-inch orifice, which was 1.75 feet above the invert. So you get a 958 invert to a 959.75. We had the top of our riser was 961.6, so about 3.6 foot deep pond, or 4 foot deep pond. And we actually had a rectangular weir at the top of the riser that was 0.6 feet by 1 foot. And then to put in the skimmer flow, you use this user-defined column. So again, when we built our pond, we built the stages so that we would have a place to enter our user-defined flow rate. So you simply, based on the testing, plug in, type in the user-defined CFS at that elevation. HydroFlow will interpolate between entry points if you need to. If the basin's over 4 feet deep, again, you can either use that flow rate, and again, you may have to slightly increase it for HydroFlow to accept it, or you can extrapolate it, or as I showed you before, you can use our Excel tool to calculate the flow rate at a deeper point, which may be slightly more accurate if you're trying to get real accurate on your modeling. And so then if you look at your outlet structure in hydroflow, normally you'll see a low flow orifice down at the bottom. In this case, you don't see any kind of orifice there. You do see your 6-inch orifice in the riser and your rectangular weir and your top of the riser. But if you look at your stage discharge, this is your skimmer flow. There's your 6-inch orifice. There's your rectangular weir, and there's your top of the riser kicking in. And just to help identify that, here's your skimmer flow from 0 to 4 feet. So you can see a very slight increase in 0 to 4 feet there. You can also, if you look at your table of flows, you look at your total flow and compare it to your other orifices. One thing to note is that your user-defined flow doesn't flow through your barrel. So that barrel flow, if the barrel is the restriction, you could have slightly more flow going out of it. But because of this user-defined, typically with the skimmer, it's such a small part of the flow that it's not going to be a significant factor, but it is something to be aware of. So in this case, our pre, we had 2.3 CFS pre 2-year, post was 2.5. So we had a 0.15 CFS increase that the city allowed for the 2-year. 10-year storm, our pre was 9.5. We reduced it down to 9. So we had a reduction in our 10-year storm. However, we did look at, in this case, because we ran SEDCAD on this and showed we had 80%, we didn't have to meet that 48-hour minimum time frame to drain. But if you looked at your outlet, flow chart, the pond had completely drained in 29 hours. And if you really look closely, the pond didn't fill up to about 12 hours. So really it's draining out in about 17, so far from the 48-hour time frame. And if you looked at your elevation table, you can confirm the pond's full, so there's not much room in that pond to try to get additional storage. But we ran just to see what would happen. We put in a smaller skimmer to increase that time to the 48 hours, just in case it would need to be done. So in this case, we got out to 66 hours. And again, it wasn't full till about 12. So that's really about a 54-hour drain time. So yes, we check the box. We meet the 48-hour minimum. Again, the basin's full, but it's not overtopping. But when we did that and we looked at our 10-year storm rates, before we had a 9.5 pre and a 9 post. This time we had a almost 11 CFS post, even though the only thing we did was change the flow rate or change the skimmer size. But what happened is we didn't get water out as fast with the smaller skimmer. Therefore, the peak elevation increased and got a higher flow rate over the top of the riser. So in this case, a smaller skimmer actually resulted to a higher peak flow rate for that 10-year storm. Again, just something to be aware of when you're running your calculations. So we're also going to talk quickly about HydroCAD. So HydroCAD is a similar program to HydroFlow. One advantage of HydroCAD is it's a smaller company and they're more receptive to doing proprietary products and making changes. So you build your ponds and model, very similar. The biggest difference is when you're building your riser structure, they have this, it's called a special and user-defined outlets. And if you pick one of those and then hit this load from file button, it'll bring up a folder that's got several proprietary products. The Marley Float Skimmer is one of them, and it has all of our skimmers with all of our orifice configurations. Now we did update our skimmer last year, and those should be updated in HydroFlow now because we've sent all that information to them. But if for some reason they're not, they are also available on our website, and you can just plug those in, and we give you instructions on how to plug them in. But advantage of this is instead of having to manually type in, your flow rate at each elevation, it automatically puts it in for you. It also has a little checkbox that you can tell it to extrapolate it to deeper pond depths, and it'll use the last couple of data points to extrapolate that for you. So just a couple of differences in HydroCAD versus HydroFlow. But we find it's a very useful, very similar program to HydroFlow. Also, if you need to check your detention time, if you've got that 48-hour to 5-day requirement, you just right click on your node report and it will give you that. You do have to go to your settings first and change your time span. Typically by default, this only goes out about 24 hours. We changed it out to 120 hours. And then it'll give you a hydrograph to show, what your flow rate in and out are, and also give you a table to make sure you're meeting that. So in this case, we're out to 65 hours. And so we certainly met that requirement. So hopefully that is a good technical presentation. We've got about 10, 15 minutes left in the hour. So if you'll indulge me, I'm gonna give you a little information more about our specific products. Everything's available on our website. It's rymarwaterworks.com. And for the most part, there's no sign up, login, there's nothing protected, it's all openly available. If you go to the Marley Float spec page, we have our design tool. That's the one without a permanent pool or permanent sediment storage. We have a basin with a permanent pool. We have a comparison chart, if you want to compare our skimmers to others. We have all of our skimmers in PDF, CAD, and we have our cut sheet or installation instructions all freely available for you. And if you scroll down this page, we have the basin details that I showed earlier. A couple of things to note about our detail. We have a new flexible coupling. This is, if you're familiar with a fern co style coupling, but we've got one with bellows in it that we use for all of our products now. So it provides a little over 90 degrees of flexibility side to side or up and down. All of our skimmers come with a orifice plate that goes in the skimmer, and I'll show a little more detail about how that works later. And again, all of our skimmers have the open, full-size skimmer or the standard orifice flow rates on them on the detail. One of the most common questions we get asked is the length of this pipe. And so the length of that pipe, we recommend it to be a minimum of 1.4 times the height of the outlet structure. So whatever that outlet structure height is, or if you don't have an outlet structure, the dam height, and that allows the skimmer to flex enough so that water doesn't come in over the top and it can get up to the top of the water. We typically like to say a minimum of 8 feet. If you had a pond that needed to go a little shallower or shorter, you could. We don't like to go excessively long because this pipe creates a lot of buoyancy and tends to lift the skimmer up a little bit, which has been some of our issues in the past, which we're now dealt with. So again, our product is HDPE. So it's a polyethylene float, HDPE pipe, stainless steel fittings. It's very UV resistant, and we'll say virtually indestructible. We've had ours put through some pretty rigorous things in the field, and they've all come out pretty well. There are no moving parts, and again, we recommend it to be used as part of the permanent outlet structure. So in the past, we had an issue with some of our products tipping, so we redesigned it last year. This is our test tank down in Fountain Inn, but hopefully this never happens in the field. But you can see no matter what is done to the skimmer, it always returns to be self-leveling and floating correctly in the basin. So it's not going to tip or twist. Not going to have any issues with that. We spent about a year and a half on R&D and testing and going through prototypes before we launched the new model to make sure we had corrected that. We do have a shielded orifice, so we have this debris guard on the outside. Flow comes below that. It can come through, but it's a very low flow rate through there. It's really designed to be coming below the debris guard. This helps to trap floatables in the basin. It increases the sediment trapping efficiency. And for post-construction, it's going to enhance your water quality, although we don't have testing yet on just the skimmer by itself. A common question recently has been frozen conditions. We will say it'll work in mild frozen conditions because we take water from probably a minimum of 4 inches below the surface. You take at least 6 to 8 inches of ice before it would really stop the skimmer. Some of the other skimmers on the market take directly off the surface, so just a couple of inches of ice could stop them from working. But because ours is below surface, it works better than maybe some others in frozen conditions. Also, I talked about our orifice plates. So hopefully this video at the top doesn't give you a headache, but shows how our orifice plate, has the different size orifices in it. there's a little metal, I call it a nub, technical term here, that is designed to make sure when the orifice plate is put in, it is perfectly centered over the outlet. And so that is engineered to provide, make sure that the contractor puts it in the right place, and super easy to change the flow rate in the field. If your pond's draining a little too fast, a little too slow. Every model comes with at least 3 and some up to 5 different flow rates. They're all third-party tested with every orifice configuration to verify the flow rates and drawdown times. We also now, for our larger 6 and 8-inch skimmers, we have a custom float. So we had to do this because this is a pretty heavy product. It weighs about 200, 250 pounds, which is needed to counteract the buoyancy of the 6-inch pipe that connects this. If you get a 20 feet of 6-inch pipe with very little water, it's extremely buoyant, tends to lift up the skimmer. So it's heavy, but we built this in with built-in handles for easier use. And if you are looking to make it for permanent use, we can do custom colors because this is a custom product. If you've got somewhere that doesn't want a bright orange float in the pond permanently, we can work with you and get you a custom color that would blend in better for that. We have 6 different models, our 2-inch, 3-inch, 4-inch, 6-inch, and 8-inch standard. And then we have what we call an 8-inch max or 8-inch with 8-inch pipe. Our standard 8-inch skimmer uses a 6-inch pipe between the skimmer and the outlet, and we get very good flow rates with that. But if we jump it up to an 8-inch pipe for an 8-inch skimmer, we get almost 2 CFS of flow rate. So that really can move a lot of water. If you've got a very large site that maybe you've had to put multiple skimmers in, which gets a little bit complicated of how you do that, you may want to consider our 8-inch with 8-inch pipe. It is a special order item. We typically have maybe 1 or 2 of those in stock, but we do ask if you need one of those to give us an extra week or so to get it shipped, just in case we don't have those in hand. But for all the other skimmers, they're basically in stock just about any time. And we get asked about pricing. This is our standard retail prices. We have not had to increase our prices due to cost of materials yet. We're getting close, but we're holding off for now. And these are very, very competitive in the market if you're comparing versus a fair cost skimmer or others. Typically, we're a little bit lower price. Not always, but in most cases we are. So I mentioned our R&D. So this was an earlier prototype version of the R&D. So I'm not going to focus too much on that one, but we've been in testing of it for over a year now. And we've kind of settled on that 2-stage version shown earlier and hope to have it on the market, like I said, within 6 to 9 months. And then lastly, before we get into questions, I want to introduce a new product. So this is our VersaWaddle. We call it our HS, or hard surface model. This product was invented out of a need. We had a couple of subdivisions that interim did not have the final asphalt down. They were using some other products to try to control flow, and they just weren't working. And what was happening is water was bypassing the catch basins and going down to a low point. In this case, the low point was a cul-de-sac with a 30-foot slope behind it, and water was jumping that slope and blowing the slope out on multiple occasions. So we developed our VersaWaddle. It is designed to prevent water from bypassing the inlet while it traps sediment. It is also foam filled, and so when water flows, the foam tips up with its buoyancy to give it a higher level of control. So if you had 6 inches or so of water coming down through the road in a heavy rain, it would trap that and kick it over to the side. Oops. But also because it's foam filled, it is designed to be driven over. So we tested these for 9 months or longer, and whether it's driven over by regular vehicular traffic or even a dump truck, they do hold up and they stay and they last for the life of the project, at least a year. We've had some in the field longer than that. They do need to be maintained. They have to just a simple spade to go scoop out sediment. We've had a contractor or two try to clean it out with a skid steer, and they're not designed to handle that, so they're not gonna hold up. But with some normal maintenance, ease of maintenance, they work very well. and particularly when you have this lip on the curb. Now, they're also excellent if you have a construction entrance that is sloping towards your main roadway, and you need something across there. You know, obviously you don't want to put silt fence or something that can't be driven over to block access. So if you need to maintain access on any hard surface, they designed to be driven over multiple times and continue to work. So that is the end of the presentation. I'd be happy to take some questions either via chat or if you want to, you should be able to unmute yourself. I'd be happy to answer anything you may have. While waiting on that, if anybody would, I know a lot of you have renewals coming up either, now or end of the year. If you'd like to receive a PDH certificate, simply email us at info@rymarwaterworks.com. We will email you a very short quiz that if you listened at all, you will not fail it, but it just verifies that you were in fact on the call, and we can send you a certificate. Got asked about a detail for the VersaWaddle. Yes, there's a detail on our website. The website is again, rymarwaterworks.com, and you just go to the VersaWaddle and there's a detail there. Again, it's available in CAD and PDF, or you can email me directly or at this email address, and we'll be glad to send that to you. And I know I've seen a couple of names here. I know we have some folks in the upstate of South Carolina. So just as an aside, Greenville County, Josh Fisher and other inspectors have seen the Waddle and have approved for it to be used. We have it in several projects in the field. So if you want to know where they are, go by and take a look yourself. If you'll email me, I'll be glad to send you directions or projects where they are, and you can go out and take a look and see how they work. But so far, our contractors have been very happy with how they've held up and performed. All right, well, doesn't look like we have any other questions. And so if you have a question later, please feel free to email me. We're happy to be a resource. And we greatly appreciate you joining us for your lunch hour today, and appreciate you considering the Marley float for your next project, and also our VersaWaddle for any applications you can use it for.
Hey, Jamie.
Yes.
Do you know of any sites in Ohio where you've done the skimmer as a post BMP, and what the OEPA, any results for working with them in any way?
I don't have any in Ohio that I'm certain of. We sell through distributors. I didn't mention that, but we sell through like Core and Main and Ferguson and Fort Align. And so we rarely talk to the end user. I will say we've been to the Ohio Stormwater Conference for just about every year that is, since 2014. And I've talked to Harry and other counties, and had a lot of people this year stop by and at our booth, and we're talking to the regulatory folks about permanent use. And so they were very receptive to that. I didn't have anybody that was like, ooh, we wouldn't allow that or something. If you do have a regulatory agency that you'd like some help with, we're happy to reach out to them and do any legwork needed to get them to okay it. Ohio EPA has included us in their design tool for their during construction. So we're one of the skimmers listed on their website, but we have not, and I know they're updating their rainwater manual right now, and I've reached out to John Matthews about, possibly including this, not only for during construction, but post-construction. So I don't know where that stands, or, I haven't gotten feedback if he's going to do that, or, put it in the manual as an option. But we have not had much resistance once people understand it's an HTP product.
Okay.
Okay. Any other questions? Don't want to cut anybody off that may have one.